does your body feel like in zero gravity?
What inspires you to become an astronaut?
What exercise do you do? And do you sweat in space?
Would a yo-yo work in microgravity?
So it works.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. We are ready for the event.
Laurel Public Schools, this is Mission Control Houston. Please call Station for a voice check.
Station, this is Laurel Public Schools. How do you hear me?
I've got you loud and clear on the International Space Station.
Wonderful. Today we are celebrating Space Day at Laurel Public Schools and our long history of NASA Hunch classes. My name is Ayla Grandpré, and I have been in NASA Hunch at Laurel Schools since I was in the 5th grade. Currently, I'm a senior at Rocky Mountain College, where I helped send a research project to the ISS 2 years ago. Last summer, I interned with the veggie team at KSC, which you are using to grow fresh food on the ISS right now. Last year, our NASA Hunch students Ethan Gradwell and Sam Little designed a new lid for the trash bag container on your galley table. Today, our first question comes from Cash Golden.
In the future, what advancements do you expect to see in space travel?
That's a great question. The advances that I hope to see is sorry about that. The advances I hope to see are advances in propulsion, in giving us the ability to move quickly through space so that we can travel farther without exposing astronauts to the harsh environment that exists out there for us.
Awesome. Thank you.
What was going through your mind when you left Earth and went to space for the first time?
Well, I can tell you that the first time I launched into space, I had what we call the fear of the unknown. I really didn't know what to expect, and there's nothing that quite prepares you for the launch of a rocket, especially a space shuttle. And it was quite an exciting ride. I wasn't sure if I was going to make it through, but fortunately, 8 minutes after launch, we were floating freely in space.
Okay, thank you.
How does fire react in space?
That's a great question. The fire that we know on Earth takes its form mostly because of gravity, because of the effects of gravity. But in space, you know, we don't have gravity. So I can sort of illustrate what fire does in space by showing you a ball of water. And fire does the same sort of thing. It actually forms a globe of flame, and it just floats in front of us or off of the end of the wick wherever it's burning from. So you get the idea that many things in space don't react the same way they do on Earth because we just don't have the gravity here.
Why did you want to become an astronaut, and how'd you go from a mechanic to an astronaut?
That's a good question. I'm not really sure how I got from being a mechanic to becoming an astronaut, but I can tell you that growing up as a child, I was always interested in space and space exploration. I grew up watching science fiction television programs and movies, and I always believed that when I grew old, or when I became older and after I received my education, that I would have an opportunity to work and live in space. And my dream came true by keeping those goals in sight.
Thank you.
What can the world of Earth-dwelling nations learn from an international space station?
Well, I think the primary thing that we can learn from the International Space Station is global cooperation. We live and work every day up here with our international partners. Right now we have a Japanese astronaut on board, and we're living with 2 Russians who work in the Russian segment, and we've launched with the Russians into space. In fact, our cooperation with them has been pretty well seamless since the early 1970s, and so we do a lot up here that I would say breaks political boundaries and breaks through them and allows us to work together as a team. And I think that's one of the best lessons we can get out of the International Space Station, is how to work together.
How are your suits designed to help protect you from solar radiation on spacewalks?
That's a good question and something that we struggle with all the time. I can tell you that a 6-hour spacewalk is equivalent in radiation dosage to about 1 day on the International Space Station. So we're outside for roughly 6 to 7 hours in that spacesuit, but that's like being inside the space station for roughly 24-hour periods. So we get an additional amount of radiation while we're out there. Fortunately, the International Space Station is flying below the Van Allen radiation belt, so we actually are protected from a lot of the dangerous effects of deep space. But our helmets are made out of polycarbonate, just like a pair of sunglasses are, our helmets and our visors, so that protects us from the sun's infrared energy. And for deep space exploration, where we're worried about neutrons from the sun, those are going to require more advanced capabilities, probably the use of hydrogen and hydrogen shielding to keep us safe, and maybe magnetic shielding as well.
Thank you.
Growing up, did you ever believe that you would end up in the ISS?
No, not really. I struggled in high school. I wasn't a great student. I had a lot of interests outside of school. One of them was mechanics. And after high school, I went to community college for 3 years before I went on to university. So it was a long path for me to get here. I wasn't really sure how that was going to work out, but I always stayed positive and stayed focused. And at some point took responsibility for my actions and my own life and stopped relying on others to take care of me or lead the way. And I think that's a key lesson, is that at some point for all students, you reach a point in your life where you have to take control. You have to start making those decisions and think about what it is you want in the long term for yourself, and then go for it.
Thank you.
What has been your most memorable or favorite mission that you have had the opportunity to partake in?
Well, it's really difficult for me to claim a favorite. I've had 3 very different missions. My first flight was the repair of the Hubble Space Telescope early in 2009. My second flight was 2011, which was a visit here to the space station, but only for about 2 weeks. And then this mission is 6 months living on the ISS. So, in fact, each of my space flights have been very different, and it's hard to compare one to the other. But I do feel lucky that I had an opportunity to see and work on the Hubble Space Telescope.
Okay, thank you.
How has your understanding of the universe changed from seeing it from space?
That's a good question, and one that I think all astronauts eventually struggle with, is finding our place in the universe. And I can tell you, as an astronaut, seeing the Earth in space and seeing distant space without being off of the surface of the Earth really makes us realize how alone our planet is, and makes us realize the fact that our planet itself is a spaceship that we're all traveling on, and we're all traveling on this one spaceship together. So that's something that I ponder every time I look out the window and look into space, is where do we fit into all this great expanse of infinite space?
Thank you. Would you do a backflip?
That was one of my worst backflips, I'd have to say. But thanks for the challenge.
Thank you.
How does your body feel at launch?
At launch, your body feels like it's strapped into a rocket that's about to blast off into space. It's a little worrisome, a little nervous, and once the rocket takes off, you get pushed very far back into your seat as if somebody's sitting on you. And usually what's going, well, the 3 times that I've flown into space, each time what's been going through my mind is that I really hope that the rocket knows which way it's going, because we had clearly left planet Earth and we weren't coming back anytime soon.
Thank you.
What determines which countries are able to send astronauts to the ISS?
Well, I think what determines that is international agreements, and nations have to show an interest, and generally the way that we operate in space together, especially on the International Space Station, is through collaboration and contributions to the program. So those who currently participate through a combination of providing money for a common pot of expenses and then also providing services. For example, Canada provides the Canada Arm 2 to the International Space Station. The Japanese have provided the Japanese experiment module. The Europeans have provided the Columbus module. So each nation provides some component of operations and or funding to the group altogether so that we can operate as a united partnership.
Thank you.
How do you overcome political and cultural differences with other crew members aboard the ISS?
I think the way we overcome that is by knowing that we all have a common goal, and that primary common goal is to stay alive. The secondary common goal is to protect the spacecraft and keep it in one piece. And then the third primary goal is for us to all achieve mission success. So we're all in this together. We train together. We live together before we fly in space. We know why we're here. We know that this is a great opportunity for each of us. And I think because of that, that common bond, those common interests, that allows us to work together effectively and efficiently as a team.
Thank you.
When you went to the space station for the first time, did you ever question your decision to go?
Every time I've climbed on a rocket, I've questioned my decision to go.
Thank you.
What happens if someone becomes seriously ill?
Well, for someone to become seriously ill, we really need medical attention, perhaps in the form of surgery. We would have to return to Earth. And we can leave the space station and be back down on the planet within about 3 hours. The challenge is, depending on when we undock from the space station and do our deorbit burn, that's what determines where we're going to land on the surface. So for an immediate or urgent departure, we would try to still plan the departure time so that we could land somewhere that we could get medical attention, because after all, that would be the point of leaving, is that somebody really needs to seek some medical attention. But generally, we can handle minor things. We can handle stitches. We can even handle cardiac arrest, but that would, of course, lead to further medical attention that would probably require us to come home.
Thank you.
What is the evacuation procedure in case anything aboard the ISS malfunctions?
Generally, if something malfunctions, we try to fix it before we leave. If that's not possible, there's a few things that we will leave for that will cause us to have to depart, and that's a critical failure of some of our life support systems, a fire in the International Space Station that we cannot extinguish or isolate to a single module, or a rapid depressurization where there's a hole created inside and we can't keep pressure anymore to allow us to maintain our breathing air. In that case, and in all of those cases, each crew member goes to their respective Soyuz spacecraft. We fly up in groups of 3, so we return to our Soyuz transport spacecraft in that same group, and we close the hatches, we put on our spacesuits, we undock from the space station, and we go home.
Thank you.
What impressions have you had about the world from what you have observed in space?
Well, the impression that I have about the world and my observations from space is that there are no borders on the planet that we can see. And it's really difficult for us to understand why it is that we have such suffering and fighting on the ground when from space it all looks homogeneous. It all looks like one world, one unified people, and it's unfortunate that we can't be that way and work harder together as a group, as a team on the planet.
Thank you.
As an astronaut who has had several missions to space, how have the projects built by Hunch students made your missions easier?
That's a great question. We see Hunch products all over the space station, and we're always excited when we get a new one. It was mentioned at the beginning of the interview that we've got a new trash can coming up, a new lid for our trash can. We're excited about that. We have challenges with managing trash in space. That's always a problem for us. And something that we use frequently every day, multiple times a day, are our food storage containers. Those have been really helpful and beneficial to us to manage our food and help us with something that we do all the time, which is eat. You know, we all need energy to survive, and eating and having food and access to that food is something that's very important to us. And we also have a privacy curtain up here in space that was designed by the Hunch kids, and that allows us to do hygiene, basically take sponge baths behind the curtain, gives us some privacy in a place where we otherwise don't really have any privacy. So the Hunch program has been great for the work that we do up here. We're always seeing new and exciting things, and we're very, very interested in the fact that it's a great way to get high school students engaged in thinking about longer-term plans and career opportunities and be part of the space program. I mean, the things that the Hunch program does is working up here right now in space and helping us with our long-term goals of living in space and exploring the cosmos.
Thank you.
If a piece of space debris hit the space station and a section of the space station was damaged or destroyed, what would the emergency protocol be to resolve it?
Well, generally the protocol for us is if we have a piece of debris or a hole punched in the side of the space station, the first thing we do is we determine how much air we have left. And we do that by taking a hack on the watch to understand when the start time was of the emergency, looking at our manovocumeters or our pressure sensors to determine what the rate of pressure drop is on the space station. And based on that information and knowing what the total volume of the space station is, we can calculate how much time we have remaining before we lose so much air pressure that we would go unconscious. And so we work backwards from that time. We try to fix the problem. First, if the leak is not too large, we'll try to locate that leak. And then we have a patch repair kit or a few patch repair kits with pieces of metal and aluminum in them and sealant that we could place over a small enough hole to actually seal the space station back up. If we couldn't do that and we got to the point where the leak was too large and we lost too much air, we would have to depart, similar to the ways that I talked about a little bit earlier, by retreating to our Soyuz spacecraft with the respective crew members for that vehicle, putting on our spacesuits, and then departing the space station.
Thank you.
Do you have any communal games or activities you enjoy with fellow crew members?
Absolutely. Doing somersaults is one of them, but you can see I'm still working on my technique. The other things we like to do is watch movies together, and we have a couple of guitars up here, and actually 3 of us on board, myself, Ricky Arnold, and Scott Tingle, are all guitar players, and so we like to play guitars occasionally on Friday nights or Saturday nights. So we try to have fun when we can. We do get some time off on weekends, and that's a nice time just to talk about the week, unwind, and get ready for what's next the following weeks.
Thank you.
You are no doubt familiar with the pale blue dot photograph from Voyager 1 and Carl Sagan's thoughts about it. Look again at that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you've ever heard of. Every human being who ever was lived out their lives. In those quiet moments during your prior 2 expeditions, and now on this one, what did and what do those words sound and feel like from up there?
Well, as I already alluded to, you know, for us as astronauts, we are lucky to have the perspective of Earth that we have. And it's not the same perspective that we see in the pale blue dot image, but it's partway there. And my hope, and I think the dream, hope and dream of a lot of us as astronauts, is that the rest of the population of the world someday, or a larger population of the world, has an opportunity to see Earth from low Earth orbit and see space from low Earth orbit. And I think that would change all of us and help try to fix in people's minds where we really fit in all of this enormous expanse. And I can tell you it's quite humbling to be up here, to look out and know that I don't believe we're alone, but we really are alone here on this planet. But I do believe there are other forms of life out there in space. I can't understand how there can't be because of how long we believe the universe has been around and how expansive it really is. I like to say there's a lot of space in space, and so I think there's a lot of opportunity for life. And my only hope is that more people would have the vantage point that we have to help us all understand where we fit into it.
Thank you.
Can you see storms on Earth from space?
Absolutely. We see storms on Earth every day. In the daytime, we mainly see clouds, large cumulonimbus clouds, and we can see those cloud towers growing off the planet. At night, we can see the lightning flashing, so when we're flying over the dark planet, we see city lights, but where we see storms, we see lightning flashes all over the place. And that's one of the most beautiful things that you can observe from space is a thunderstorm.
Thank you.
What is the scariest thing that has ever happened to you on a spacewalk?
Well, I can tell you that I almost let go of the space station once while I was moving around out in space on a spacewalk. And although that's not the worst thing that can happen, it's not one of the best things that can happen. Fortunately, we have a tether, a metal tether, like a fishing reel that keeps us attached to the structure. But letting go is never a good thing because it's always going to be a bit of trouble just to get yourself back to the space station.
Thank you.
What experience has been the most surprising or unexpected about living in the space station?
The most surprising thing to me about coming to space, and this has been true every time, is how quickly the human body and the human mind adapts to a microgravity environment. To you, it may seem very strange that I can let go of this microphone and it will float in front of me. It'll stay there as long as I want it to, as long as air doesn't blow it or I don't bump it. And if I bump it or air blows on it, it'll move. But on Earth, obviously, that doesn't happen. If you let go of something, it will fall right to the ground. But what amazes me is that, to me, this is all very normal now. The fact that I don't have to walk in here, instead that I fly through the middle of the space station, that seems perfectly normal, like it's a normal part of life and that everybody does it. But in reality, only astronauts or people that have been in space have been able to do that. So that's what surprised me the most, is how quickly the human body can adapt to the environment that it's currently in.
Thank you.
What kind of medical and mental testing training does an astronaut have to go through to be able to go up into space?
Well, I think, astronauts in general just have to be in good health and have good levels of fitness. And mental stability is important as well, and the ability to get along with other people. We spend a lot of time working on our behavioral performance. That's really our skill set related to getting along with others and working with others that have maybe different backgrounds and are from different cultures. And what we learned during our time and during our training is that it's as important to be a follower as it is to be a leader. And the key is to recognize when you should be a follower instead of a leader, or when you should be a leader instead of a follower. So we work on those skills, those behavioral health performance skills, and then physically and medically, we also try to maintain a certain fitness level, and we receive daily medical checkups on a regular basis to make sure that we don't have any chronic or critical issues that would affect us while we're in space.
Thank you. Thank you for your inspiration today.
Well, thank you all for joining us on the International Space Station. I hope you learned something today, and I hope in some way that we've inspired and excited many of you to get involved in human space exploration. I think that this program and these opportunities are just opening up to the general public, and I think in a short period of time, probably within the next generation, we will be living permanently in space, and probably not on the space station, but maybe on the surface of another planet.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants from Laurel Public Schools. Station, we are now resuming operational audio communications.